This question says, a ball was thrown upward at an initial speed of 48 feet per second. The point of release was 5 feet above the ground. And let t be the number of seconds after the ball is released. With the height equation given by h of t is negative 16t squared plus 48t plus 4. We want to know what value of t results in a height of 36 feet. So we're throwing the ball up. It's going to get 36 feet or possibly higher than 36 feet and then come back down. So that might indicate to you how many possible solutions we're going to have. So we need to find t when height is 36 feet. That's our goal. Find t such that h of t is 36. Okay, h of t is 36. Negative 16t squared plus 48t plus 4. This is a quadratic equation. We would like to have a quadratic equation equal to 0, so we will subtract 36 from both sides. And we get 0 equals negative 16t squared plus 48t minus 32. Now let's look at this for a minute. What is our strategy we want to use here? We certainly could try to factor it, but with numbers this large, that's pretty tricky. We could go to the quadratic formula again. B squared is 48 squared. Wow, very, very large numbers. So the first thing I should look for is, can I factor something out of all three of those? And you recognize 2 goes into all three of those terms, as does 4, as does 8, as does 16, but I'm actually going to factor out negative 16. So negative 16t squared divided by negative 16 is t squared. Positive 48t divided by negative 16 is negative 3t. Negative 32 divided by negative 16 is plus 2. Now negative 16 can't be 0, so therefore I have my quadratic equation. T squared minus 3t plus 2 is what has to be 0. And how am I going to solve that? You could use the quadratic formula or completing the square. I am going to go ahead and try to factor it. So let's do that. T squared is here. Here's plus 2. The middle adds up to minus 3t. T times t is t squared. How do I get 2? Well, positive 2 times positive 1 is not going to give me negative 3t, but negative 2 times negative 1 will. So we get negative 2t and negative 1t adds up to negative 3t. So we've successfully factored it into t minus 2 and t minus 1. Now let's think about what that means. So I have 0 is t minus 2 times t minus 1. So t minus 2 is 0 or t minus 1 is 0. So t is 2 or t is 1. Now what does that mean? Well, remember, we're trying to find out when does the ball reach a height of 36 feet. So the ball reaches a height of 36 feet both 1 second and 2 seconds after release. (36 feet 1 second after release), so that's on the way up, and 2 seconds after release. Now the next question was to find out what is t when the height is 24. So let's continue. We have our same height function. So we have h of t is negative 16t squared plus 48t plus 4. And our goal is to find t when the height is 24. So if that's the case, we're going to say 24 equals negative 16t squared plus 48t plus 4. We will subtract 24 from both sides. And we get 0 equals negative 16t squared plus 48t minus 20. Now again, I could try to factor this. I could go to the quadratic formula. I could even try completing the square. But let's see if we can factor something. 2 into all of those, 4 into all of those, 8, no, not into 20. So I guess 4 is the best I can do. But I'm going to factor out negative 4 so that my leading term is positive. Negative 16 divided by negative 4 would be 4t squared. Then we have 48 divided by negative 4, negative 12t. And finally, we get 4 minus 20, right? We get negative 20. And negative 20 divided by negative 4 would give me 5. Negative 4 can't be 0, so I need to solve the quadratic equation. 0 equals 4t squared minus 12t plus 5. Now, I could try to factor that, but instead, I am going to try to use the quadratic formula. To remind you, t in this case, instead of x, will be negative b plus or minus the square root of b squared minus 4ac, all divided by 2a. In this case, a is 4, b is negative 12, and c is 5. So plugging all that in, I'm going to get t equals negative b, negative of negative 12 is positive 12, plus or minus the square root of b squared, negative 12 squared, minus 4ac, 4 times 5, all divided by 2a, all divided by 2 times 4, which is 12 plus or minus the square root of 144 minus 80 divided by 8. 144 minus 80 is 64, so as it turns out, this could indeed have been factored. So we get t is 12 plus or minus the square root of 64 over 8. So t equals 12 plus or minus 8 over 8. So we get t is 12 plus 8 over 8, or 12 minus 8 over 8. 12 plus 8, 20 over 8, or 4 over 8, which reduces to what is that, 5 halves, 1 half, but let's use decimals. That's probably more helpful for us here. So in this case, t could be 2.5 or 1/2. So what's our context? That's when it reached a height of 24 feet. So just to put the context back, the ball reaches a height of 24 feet. A half a second, and 2.5 seconds after release. Again, one of them is on the way up, the half second is on the way up, and the 2.5 second is on the way down. Now, you could have factored that. If you have x equals 5 halves and x equals 1/2, certainly we could have figured out a way to go ahead and factor that, although quadratic formula here isn't too bad. Now, our next question is, when does the ball hit the ground? So what would the height have to be? Remember, here's our formula. Right, h of t is negative 16t squared plus 48t plus 4. When does it hit the ground? It hits the ground when height is 0. So let us think about that. We have h of t equals negative 16t squared plus 48t plus 4. When does it hit the ground? Find t when h of t is 0. When the height is 0, the ball will hit the ground. So we have 0 equals negative 16t squared plus 48t plus 4. What do we have to do here? Let's factor out a negative 4, right? Because negative 4 goes into negative 16. Negative 4 goes into 48. Negative 4 goes into 4. So if we do that, what are we left with? Factoring out the negative 4, 0 equals negative 4. Negative 16 divided by negative 4 would be 4t squared plus 48t divided by negative 4 would be negative 12t. Plus 4 divided by negative 4 is negative 1. So negative 4 can't be 0, so this part has to be 0. 0 has to equal 4t squared minus 12t minus 1. And again, I think I'm going to go ahead and try to use the quadratic formula. So let's remember that t is negative b plus or minus the square root of b squared minus 4ac all over 2a. And in this case, what do we have? We have a is 4, b is negative 12, and c is negative 1. So let's go ahead and try to solve this. So using that substitution, t equals negative b. Negative of negative 12 is positive 12, plus or minus the square root of b squared, again, negative 12 squared will be 144, minus 4ac, 4 times 4 times negative 1, all over 2a, all over 2 times 4. So we get 12 plus or minus the square root of 144 minus negative 16, so that's plus 16, all divided by 2 times 4, which is 8. 8. Next up, we get t is 12 plus or minus the square root. 144 plus 16 is 160. That's kind of a nice number, divided by 8. Because root 160 is root 16 times root 10, and root 16 is one that we know. So 12 plus or minus root 16 times root 10 to give us root 160 divided by 8. So we get 12 plus or minus 4 root 10 over 8. And be careful with the fractions. 12 over 8 plus or minus 4 root 10 over 8. So t is 12 divided by 8, which is 3/2, plus or minus 4 root 10 over 8, which is 1/2 root 10, or root 10 over 2. So I have two numbers here where it hits the ground in theory. I have t is 3/2 plus root 10 over 2, which what is that approximately? We need an approximate answer here. 3/2 plus root 10 over 2. I'm getting 3.08. So we're saying after 3.08 seconds, the ball will hit the ground. The other one, t is 3/2 minus root 10 over 2. What is that approximately? 3/2 minus the square root of 10 divided by 2 gives me negative 0.08. Now, what sense does that make? We can't go backwards in time, so that's not really in our feasible domain, so we will ignore that. So our approximate solution, when does the ball hit the ground? What do we conclude with this? We'll say the ball hits the ground about 3.08 seconds after release. Now, we want to go ahead and check all of these answers on the graphing calculator. So let's go ahead and plug this height function, we see it here, negative 16t squared plus 48t plus 4 into the graphing calculator. And then we'll see if our answers match. So go to the y equals, and we'll type that in. Negative 16, I'm going to go with x squared. Negative 16x squared plus 48x. Plus 4. Now, one of our biggest challenges is determining a reasonable window. We're seeing it's hitting the ground a little bit after 3 seconds, so I don't need a whole lot of x. I like to have some negative, so maybe negative 1 to 4 with the scale of 1. Now, we know it's got to get as high as 36 at least, so maybe I want to go to double that for the maximum. Maybe I'll go to 72. And I want to have some min at a similar kind of scale, so maybe I'll go, whoops, that's the wrong button. Negative button is here. Maybe I'll go negative 20 to 72. And we'll make that scale 10. So up the y-axis, every tick mark is 10. And let's see if we can identify that parabola in this window. So again, we put in negative 16x squared plus 48x plus 4. And here is the parabola on the window. And that looks pretty good. And our first question was, what is the time when the height is 36? 10, 20, 36, around there. We go ahead and draw in 36. It'll come in red. So these will be the points where the graph hits 36. So it looks like I have 2 of them. We said 1 and 2 seconds. Let's see with our finder of the intersection point. So second calc, intersect is number 5. First curve is the blue one. I'm going to move towards the first intersection point. First curve is blue, enter. Second curve is red, enter. Guess, pretty close. Is it 1 second? It is, very good. And let's check to see if we get the same answer of 2. Intersect, number 5. First curve, this time move the cursor with the right arrow until we're close to the intersection point. That's pretty close. First curve is blue, second curve is red. Guess is right there is good enough. And indeed it's 2, so that's checked. That was our first question. Our next one was 24. Remember, each tick mark is 10, 10, 20, 24 is around here. Obviously, it will hit 24 height before it hits 36 in height. So it should be less than 1. And coming down, it should be greater than 2, as we see from our picture. So let's get rid of the 36, and let's make it 24. And we'll graph that one now. So here comes our parabola on our special window. And here comes 24. And we want to find out whether we get the 1/2 and the 2.5 we did when we did the computation. Second calc, intersect, number 5. First curve, move the cursor close to where they crisscross. First curve is here, enter. Second curve is there, enter. Guess is there. And 1/2, very good. And I expect the second one will be 2.5, just a quick check. Second calc, intersect, number 5. Move the cursor close to where it crosses. Takes a while to get there. First curve, enter. Second curve, enter, guess. And sure enough, that's 2.5. Now our last thing was, where does it hit the ground? Now this one that's negative is irrelevant. Remember, we had that negative 0.08. But this one out here, we said 3.08. Remember, each tick mark is 1, 1, 2, 3. Do you believe that's about 3.08 seconds? Well, let's find it. I'll remove the 24 since I don't need it anymore. And I'm going to go back and just graph the parabola. And I want to find out, where does it cross the x-axis? Where is the height 0? So I use the 0 finder for that. Second calc, the 0 finder is number 2. Left bound, you've got to go a little bit to the left of where it crosses. So that's pretty close. Left bound, enter a little bit to the right of where it crosses. And close to where it crosses. And hopefully I'll get 3.08. And sure enough, 3.08. So the graphing calculator enabled us to check all of the work that we did using algebraic strategies.